So,
220.
no, it's 201 species.
Dude, it's probably like 200 million.
Oh, it's not. Freaking answer.
200 million.
The answer is 200 species. Oh, wait, okay. That's just long hard beetles that he specified. I don't know the difference, but.
Oh my god, 1,000.
There's 200 species of types of long hard beetles here in Florida. Alright, so you guys know lots of scientists study insects because they can be very indicative of the rest of the environment. So science studying longhorn beetles in Florida use this model to approximate the number of species on an island with 8 square meters. Approximate the area of an island that is home to 20 species of longhorn beetles. Now this one's really complicated. I would have thought it would have just been something like this, like a size of island, right? And then this would be the numbers of species. And I would have thought that a small island just has a couple of species. A bigger island has more. A bigger island, a 10 square meter mile island has 10. And then I would have thought it would have just been like really direct, right? But I guess the guys who went out there, they collected all their beetle types. And then when they collected that data and analyzed it, I guess it went a little bit more like this and modeled a logarithmic equation. Here's our log equations where as the island gets bigger, yes, the species increase, but at some point you're not going to have like on a huge island a million species. I guess at some point it kind of flattens out in the variety of beetles. So it's not a straight linear relationship. It's not even a square root. This looks very square root to me. It's actually more of a log relationship. Well, and it actually makes sense because the way in biology things grow is exponential growth. Right? So, no, that doesn't make sense. So, as they relate to how much space they have to live, it's logarithmic. I don't know what that actually was. My bad connection. All right, so let's see how they solve this tricky little word problem. This says if the people go around, they collect all the beetles they can, they notice there's 20. How big of an island must that be? So what they've done is they put 20 in the S for species. And then from here, it looks really complicated, but it's really just steps that we've always taken to solve equations. Here they subtracted the 0.9, and then they divided 0.28. But this is what's brand new to you. It's after that. They say they're exponentiating each side using base 10. So they do a big base 10 on both sides, and that cancels things out, and they figured out the area of the island is 21 square kilometers. How big do you guys think like Anna Maria is? I mean, about that size. I'd say it's like 10 kilometers from one end to the other. Like, is it only 3? 3 miles from one side to the other, Anna Maria? It's bigger than 3. It takes a lot. No, isn't it kilometers? Oh, yeah. I think it might be 2 longer. Or it's like 6 miles. I think so that's like Longboat. Yeah, we got Longboat Key. Is there any difference between a key and an island? See, that's the key. How come Anna Maria Island and Sarasota has keys? I know, I think he's like it rose more recently. I don't know. Yeah, the key is like a key is like actual like part of the land that is broke, whereas island I think is more erosion. All right, let's do this. So, um, let's say the scientists they're living their life, going out collecting beetles. They find 10. How big is the island they're on? I don't remember the equation. I'm gonna rewrite it right here. The only thing you want to talk about right now is beetles or hammerhead sharks. When are you guys gonna get on board? It's been a while. I'm ready. Ready to do math. Ready? Doing good. I'm not doing this. I should see like lots of calculators in hands because you're not so
Wait, what now? Oh, look,
All right, the one thing I'm going to do differently than the book example is I'm going to use my calculator all the way through to make it look easier. Like so, your book had the subtraction still shown. I'm going to go ahead in my calculator, log 10, close parenthesis, subtract 0.929. Log 10, close parenthesis, minus 0.9202. And already our equation's looking much more simple. No, it's, oh yeah. Just do 1 minus 1.
what? It's on the board.
Yeah, now subtract.
You subtract both sides.
Alright, what's my next move? I'm trying to solve for it. What's my next move? Divide. I actually went to my calculator and did the subtraction. Log 10 minus 0.929. The same log line we did last week with the change of base. Alright, I got this far. Okay, I'm starting to, this is a long decimal. I'm keeping it in my calculator. I wrote it down, but I'm not gonna just use this number. I'm using the whole decimal in my calculator. Alright, so what is the base of log A? It's an invisible 10. Okay, so this is what's brand new to you. Alright, this is called exponentiating. We're gonna make both sides of this equation exponents. So I'm gonna do a great big base 10 and I make 0.279 an exponent. I'm going to do a great big base 10, and I make log 10a an exponent. You exponentiate. You're raising both of these up to be exponents. And you make a big base 10 on both sides. Mhm. This little guy? This is brand new to you. You've never done this before. I'm telling you, you're allowed to make a big base on both sides as long as it's the same base. Okay? Why did I pick 10? Because it's the base of this. So if this was a log 3, we would do a great big 3. If it was, yeah. So there's a property of canceling here. Yeah, this, for instance, in a situation like this, if the big base and the little base match, they cancel, and it's just x, because it really just equals 1. Okay? So now, no, because you cancel out the log. What? Right? You cancel the log. I gotta put this into my calculator. 10 raised to that exponent. And I'm not typing this actually. I did 10 exponent and I'm going up in my calculator and I'm getting the whole long decimal. Wait, so
Why you doing?
I actually used the whole thing in there. Because I still had it in my calculator. I wrote it down. Why is it that? Because like the work we did yesterday, 1.846.
I mean, that's the.
Wait, we did a problem like this yesterday. I think she's just something like this is first off, this problem started with a log, and this problem doesn't. Okay. Now, we're actually utilizing this skill to help us solve this. But look, if I cross the tens out now, I get right where I was. Yeah. I made the tens this time to cancel the log base out. So I'm using that fact in a different way.
So if we put 1.9, do we have to use the whole thing?
For our purposes now, let's run 3 Yeah. Alright, so this is significantly smaller. 20 species was like 21 square kilometers, but 10 species is all the way down to 1.9 square kilometers. That's a little baby island. You could walk around that whole island with your grandma. It's like really small. There's no roads on that island. There's probably not even a boat ramp. 1.9 square kilometers is just like only arrived by boat. Maybe you could swim out there. Any questions? Let's take yesterday's assignment.
Square.
Got it. Hey, you're gonna take my hair, okay? Because, dude, because she just does like she makes pencils.
It's actually on the ground.
Right, but you put all the folders in it. It wasn't okay, and I'm not. I'm gonna be the one that's not trash. I don't really want to take Spanish. Wait, what do I think? All this sugar.
I didn't put it. I thought we were local travel and
Wait, what did you pick? What did you pick again for your electives? Oh yeah. I don't. I don't want to take Spanish. What I rock is no. I get like should I? With like cat.
yeah, that's true. You remember his favorite outfit was like jelly straight up. It was like a cowboy.
Look, I had a bun a thingy in my hair. Bro, so it's someone took your whole back. Look at the back. Should I show this? I'm gonna show this.
Alright, another side note, I figured out what the scallop hammerhead shark is. These are the actual hammerheads that we have here in Florida. They have like an extra little groove on their.
Wait, what's your cool?
You've seen it.
Dude, they
You've
have
seen a hammerhead shark here in Florida. There's a good chance it was a scalloped hammerhead shark.
Are those more common? Are those more common?
I don't know if they're common, but if there is a hammerhead in Florida, it's probably
In water? Wait, five?
Alright, So you look at it, see what you think, ask a question. Yeah, let's move on. Hey, what was the other question besides 12? 11? 11.
I don't like this sound. They're the only sound. They'll give us a test.
Log E is the same as natural log. The calculator doesn't do log E. The calculator I log E. What'd you say? Yeah. Let's move on, please. Let's move on. Let's move on. Let's move on. So, there's I can hear from your questions that there's quite a bit of confusion between what we're doing with these spaces and these logs, and that's okay because it's getting introduced to these topics for the first time. So it takes time to navigate through. Now, all of the equations we've been working on for the last 2 days have besides the veto question, they have all started in exponential form. They've started without the word log. They have not started as log equations. Today's equations start with log. Okay, so it's a difference. Did I start with a log in my equation, or did I just start with a base and an exponent? This is what happens if it starts with a log. Okay, so it says at the top, it says solving log equations. Our list the last 2 days said solving exponential equations. Okay, so this is just a little bit different. The exact same section. It just goes like after number 14 or something. Okay. So there's 3 types of problems. The first type is that it's the same log on both sides. That's the best case scenario, where you can just cancel out. You don't have to write this example. We're going to do one, but I'll just show you visually for a second for instance, if it was log base 5 of 2, log base 5 of x, the log 5's cancel, and 2 equals x. Okay, so this is going to be your most basic.
Is it 1?
No, this is 2 equals x.
No. The
Yes, type
Type
1.
one.
Type 1. That's type 1.
spell doesn't have that.
Yeah, here's a brand new word for you. Exponentiate. Exponentiate. Yeah. Exponentiate means you make both sides exponents. We just did it with the Beetle problem. So I'll show you a quick example of that. So exponentiate would be like, that would mean you only have one log. So what if it was like this, where you don't have a log on the other side, you can't cross off. What you do is you make a great big base and you turn them both into exponents. So I would write a huge 5, and these things become exponents. And then there's a canceling property here, and you would just have 2 equals 5 to the x. Isn't a great example? And then the third type is you have to use a condensed property first. So sometimes you have to use, when we were expanding and condensing, we're going to have to utilize some of that for the most difficult problems in this part. So first you might have to condense and then you do one of these things.
I'm just really confused on like how you can just generate
Oh, you're right, because it's the first time you've seen it, but we have even something really simple like this. We're generating a -5 on both sides.
But not really, right? Because you know where the 5 comes from.
Right. But here, I also know where the 5 comes from.
Is there just more math?
Yeah.
Like what allows
It equals 1. It equals 1. I haven't had a. So let's say I took this. This is an exponential. Let's say right here. Yeah, I don't have a good way to explain it right now. Yeah, maybe one. Are we ready for 1 and 2? Yeah. Okay, let's get into it. We're kind of running out of time here. So 1 and 2, you have a log base here, natural log on both sides, cross them out. And it's just 5x plus 2 equals x plus 10.
What?
Peyton, was it a geometry book? It wasn't an algebra 2 book. Well, I completely false. There's you trying to hold conceptions about humans. Would you be willing to go pick that up? And I'll give you extra credit. I'll let you go for a while.
Extra credit? Like,
Yeah, can we charge you by ourselves?
Never mind. I don't want to Wait. If I take this, I got Just go back to this 30
Humongous 3. Humongous 3. Now everything becomes an exponent. It's whatever that number is.
Just three? Or a lot? You know, like, why do we have
You're going a little fast.
Two logs to one or 3 to 1. So I had 2, I reduced it down to 1, and I multiplied the arguments because addition and multiplication are related with exponents and logarithms. What do you mean reduce? So that was a lesson from I think where we were condensing and expanding. So we're utilizing that skill now. Yep. Yeah. So, actually, we're gonna make it equal to 0 first, and then we're gonna GCF that.
Oh, wait. There's a couple.
Oh my gosh.
Whoa, wait a minute.
Always factor.
Yeah, then you factor it. If it's a quadratic, you factor it. So
Hold on, miss.
at the end of every chapter, they like to make every equation end in a quadratic so you can still remember how to factor it. Anyway, this
Okay, that was
factors
actually
into the answers are 3 and -2. But guys, there's a rule. The whole reason I showed you this example is you wrote a definition on day 1 of log that looked like this, and it said y must be positive. So if you end up with an answer that gets plugged in and creates a negative log, you reject it. So well, we got two answers here, 3 and -2. When you plug -2 into the original, it breaks this rule. So -2 can't count, only 3 counts.
Wait, guys, I forgot how to stack.
So -2 would put a -12 in, and you can't have a negative argument.
Now I'm done. There's the assignment. 6, 10, 20 to 30, so you have 5 minutes starting right now and stop all of your off-task conduct.
Too much excitement on a Friday.